Alright, and welcome back. Today I'm going to do a short video on preparing your solid model to be 3D printed, and then a little demonstration on using the software to get an estimate from the solid model. So first of all, we need to open one of our models that we've created, and so I'm just going to pick one of these. How about that one right there? And once we have it open, all we really need to do is we just need to do a save as, and then pick from the file type. We need to change that and make it an STL file. And then we can leave it called the same thing, or we can change the name, either one. And we save it. Yep. Alright, and now we can go to Cura, which is the software program that we're going to use for estimating. I really didn't change anything in the settings. I left everything as default. The only thing I changed is enable support material. This was not checked after installation, so I checked that, but that was really the only change that I made to the settings. So now I'm going to come over here to open file. There's our STL file that we created. We're going to open that, and if we don't do anything with the positioning, it automatically analyzes it and tells me it's going to take about 4 hours and about 2 meters of material to create that. Now, to give you an idea of what that is, the infill, this is what's going to do on the inside of the part. We can do a hollow fill, which is going to be slightly less, about 3.5 hours. We can do a dense fill, and that's going to take about 4.5 hours. If we make it solid, we want it to be a solid block, it's going to take 8 hours and 15 minutes and a lot of material. Usually a light fill is good, unless your part is not going to be very heavy or have a whole lot of structure to it. Hollow is not going to have anything on the inside, so there's not going to be any strength whatsoever in it. But usually a light fill is good enough for most parts, unless you're actually going to use the part for some purpose, and then you might want to go to a dense or a solid fill. I chose the PLA. That's standard material for 3D printing. Some of these other materials, if you happen to know that a machine can use it, you can change it to that material. And there's other options in here that I'm not going to go into, at least at this time, but there's lots of settings here very specific to 3D printing, and you can make a lot of changes and do some really specific stuff in setting this up for the 3D printer. But just to get a time estimate and a material estimate of what it would take to make your part is really what we're doing here. We can try to see if we can manipulate the part. However, I do have to be honest, I have never used this before, so I'm not really sure what I'm doing. Let's see, let's rotate this in this general direction. We want to go 90 degrees. Come on, come back. There it is. There we go. And that creates a much nicer time. It cut my time almost in half, and the material usage didn't really knock down the material usage a lot, but if we zoom in here a little bit, we can see that now my part is laying down more more like you would expect to be efficient for the 3D printer. Now, I want to go ahead and rotate this around this way. And it didn't bump up the time and material near as much as I thought it would, but this arm out here that's now out in space, that's what this support material is for. It'll build up material here to allow that support, unless the material can be easily added on and support itself out here. That support material will hold this up until we break it loose after printing. But to show you really quick that this configuration is going to be a much nicer configuration for printing this part. Plus, you always want to think about, if the 3D printer is up here and it's placing material and it's building it up as it goes, this surface is not going to be near as nice as this surface is going to be, and this surface here, which for a part like this, that might not be so bad. And if we really wanted to use this part for whatever application, we could go back into this hole with a reamer and clean that out and make it nice and smooth if we needed it to be so. It's not going to be too bad of a finish just having it printed, but it's going to have little ridges, kind of like, if I can zoom in here a little bit, kind of like what you can see here in the image. It might not be quite to that extreme, but it is going to have these little ridges in here. So that's something else to keep in mind when you're doing your time estimate and placing the part as an idea of how you want it to be printed. So with that said, these are the numbers that you want right here. You want the time, and you want this amount right here. Now you can use the weight, but really it's the amount of material, which is the 1.73 meters in my case. So that about does it, and that concludes this demonstration of how to take a 3D part and get a time and material estimate using Cura.